Alright, this is the third video that I've made of talking about graphing quadratic equations. This video's intention is going to be to focus on what's called the intercept form, or sort of a factored form as it's often called, where we've left it separate instead of having standard form where we don't have any parentheses at all, or vertex form where you have that perfect square idea, x minus h quantity squared, where h and k are your vertex. In intercept form, it's helpful because you can identify very quickly and easily the x-intercepts of your graph given to you by p and q in your factored form equation. Then from there we can try to use other methods to try to find more points on our graph. But again, those two x-intercepts are fairly quick and easy to find, assuming you can be in intercept form. So let's go ahead and take a good look at a first equation here. Notice on the left we've got y equals 2 times x minus 3 times x plus 1. Again, taking into account that x minus p and x minus q, p and q are going to be your intercepts, your x-intercepts. That means that we have x-intercepts at 3 and 1. Make that negative 1. Notice that it's x plus 1, and the quantity is normally x minus q. So that would be a negative 1, 0. So we can plot those points right away. 3, 0, negative 1, 0. Now, knowing that parabolas have symmetry, we can use that idea to try to help us find the axis of symmetry, thus also getting us the x-coordinate of our vertex. What's halfway in between our 2 points should be our axis of symmetry. So looking at where our points are, it appears to me that x equals 1 should be our axis of symmetry. Again, a great way to do that algebraically is to sort of find the average. P plus Q over 2 will give us the x-coordinate of that vertex. So we can double check by saying 3 plus negative 1 over 2, which is 3 plus negative 1 is 2 over 2, and notice we do get 1, or x equals 1, for our vertex. So then that's a great place to start our table. I'm going to start my table at 1, count my way up to 3, and count my way down to negative 1. And the nice part is we already know that at 3 we get 0, and at negative 1 we'll get 0, because negative 1 plus 1 would have been 0, and then multiplied by our other 2 terms it will give us back 0. Same thing if we plug in x as 3. 3 minus 3 is 0, 2 times 0 is 0, and 0 times x plus 1, no matter what it may be, was going to come out to 0. Now to find our other coordinate points, we are going to have to actually plug in some numbers. So go ahead and take a second, plug in 0, 1, and 2 into your equation. And if you do so, you'll quickly find out that when you plug in 1, you get negative 8, and when you plug in 0 or 2, you'll get negative 6 both times, which makes sense with our symmetry. Remember our 1, 3, 5, 7 method, if you've learned that. This 2 in front, remember, is doubling the rate at which we're going to go up or down. So from our vertex, we're going up 2 units instead of 1. From that point, we'll go up 6 units instead of 3. We're going up twice as fast as 1, 3, 5. We're going to go up 2, 6, 10. So go over to 1, and it looks like we only have 5 lines. So to get to negative 8, we better count by 2's. So I'm going to label this negative 10 down here, which makes this negative 8 on the next line up. Then we can go to negative 6 over at 0, and then back to our intercepts. And if you want to, you can even go 1 point farther. We go to 4. We went up 6 units. Now I got to go up 10 units. And since we're going up by 2's, we can actually reach 10 right up here. There you go. Let's go ahead and label something on the x-axis as well. So now we can go ahead and graph our parabola as smoothly as possible, reaching down to our vertex and then swinging back up again through our points. We've got our axis of symmetry, we've got a nice smooth line, and it looks like a pretty good graph. Go ahead and try that same idea of finding your intercepts and your vertex on this equation. I'll fill in the table, most of the graph, and we'll work from there. Alright, I went ahead and took my intercepts, found that negative 2 and positive 1 will give me my nice x-intercepts. Also, added them together, cut them in half, and found out that negative a half is going to be my point, or my axis of symmetry, running right down the middle. Therefore, a great place to start your table is at negative a half for x. When you plug that in, you'll get 2.25, and that's where your vertex will occur, which is what we have right here, just a little bit above 2. Then I found a couple other points around -0.5. Remember, you could still use symmetry. You just may not get the as nice of points or as easy to find of points as you often would with the 1, 3, 5, 7 method. The unfortunate part is we don't have that nice whole number going on in the middle, so it gets a little bit tricky that way. But being a negative a value in front, our parabola did open down. We found some nice points, and hopefully your parabola came out looking as nice as mine did. I hope that helps you graph from intercept form. Good luck and happy parabolas.